Hi guys, hope you will be doing well. So this is the day 3 of system design, and in the day 1 I actually told you that how are the system design interviews different from a coding interview. So they are different because there is no one pattern like every lead code problem has a specific pattern, but system design questions, there is no specified pattern. Interviewer asks open-ended questions, and we have to make architecture diagrams. And so questions are open-ended to test our knowledge. So we have to understand the requirements and design the system accordingly. So, so how to ace those interviews? In this post, I will put the link in the description. In this post, I told you that which skills are required. So problem solving skills are required, and communication skills are required in this interview. So you can check this post. And so to have a good knowledge about system design questions and system design concepts, I started a second post. In the day 2, I actually told that what is meant by system design. I will put the link of this post and the video in the description of this video. So after discussing that how system design interviews are different in day 1 post, and in day 2 post, I actually move towards that what is actually a system design, and then we move towards that what is the difference between functional and non-functional requirements. Before this, I actually told you that why system design is required. So actually so you can check this post, and I also made a video on this day 2 content, so you can also check that. So in this video we will discuss that what is a monolithic architecture, and what are the disadvantages and what are the advantages, and then we will see that how to scale a monolithic architecture, and then we will see a difference between monolithic and microservices architecture. Then we will see when you should choose monolithic architecture, and then last but not least, why companies migrate to the microservices architecture. So before deep diving into a monolithic architecture, let's first understand the word of monolithic. Monolithic means a single large block. So imagine a one restaurant as a single building where there is not only the kitchen room but also a manager office, cashier place, and a dining place. Imagine a few customers come to the restaurant, so the single building will serve those customers. But imagine a situation where the kitchen becomes faulty, then all the customers will be affected. So what are the solutions? Solution is that you purchase a new big building so that you can handle large customers, because kitchen area will be increased, chefs will be increased, and waiters will quickly charge the payments and quickly serve the meal. This is one of the approach. Another approach is to build different branches of a restaurant. Monolithic says that you should have a one building and you are acquiring all the resources in that building. So monolithic means single large block. So in it is an architecture where different components like payment, notification, all are combined into a single deployable unit. So what are the components of an application? Well, you know that there is a UI, and behind the UI there will be a middleware, that are the shared helpers to check authentications and error handling. After middleware, there is a controller or a business logic. That controller or a business logic will be dealing with the data access layer, and that data access layer will be querying the database. And since in our system we have like payments component and payment module, for these modules we need external dependencies like Stripe. So if all these components are combined into a single deployable unit, this architecture is known as monolithic architecture. Let's discuss some characteristics of monolithic architecture. The first characteristic is that there is a single code base. Like Ruby on Rails developers know this thing, that Ruby on Rails applications are um, monolithic, means front end and back end code is present in the single repo. Like I recently built a project code editor, so all the front end and back end code is in the same repo, means there is no different repos of FE and BE like they mostly exist for the Node.js applications. Another characteristic is shared memory. Since there is a single process, no different threads are there. So as there is a single process, so memory is shared, means a controller can easily call a service method, and all you need is just a method call instead of network requests. Another characteristic is centralized database. As I said earlier, that in monolithic architecture there is a single code base, single database, and all they are deployed as a single unit. So since we have a single database, so consistency is achieved easily. Since we do not have distributed systems, so consistency is there, and due to the inter-process communication, our operations of read and write are fast. Fourth characteristic is easy deployment. Since all the application is deployed as a single unit, so whenever we update or deploy anything, everything will be changed. Last characteristic is limited scalability. We do not have independent scaling. Although we can scale our monolithic architecture, we will discuss that in the later section of this video. But remember that a monolithic architecture does not support independent scaling. This is the downside of monolithic architecture. Now let's come towards the advantages of monolithic architecture. So monolithic architecture is easy to learn. No extra setup is required, and easy to manage as well. Advantage is that it reduces our cost, since we do not have to buy extra infrastructure, extra DevOps, or any extra different monitoring is required. That is why it cuts short our cost. That is why this architecture is perfect for small or initial MVPs. Another advantage is speed or performance, that monolithic architecture applications are fast. Why? Because it reduces the network request, and there are just method calls between different components. That is why they are of high performance. Advantage is it that monolithic architecture applications are faster to develop, since there is a just single repo, and everyone will clone them and push changes in it. That is why the development is fast. Last but not least, the major advantage is easier debugging. Since there is a single process and the logs are centralized, that is why errors are easily captured, and easily we can debug different issues. Now let's come towards interview question, that can we scale monolithic architecture? So the answer is yes, we can scale monolithic architecture, but the issue we will discuss in the disadvantages part. But yes, we can scale it. The first approach is vertical scaling. As we know, vertical scaling means adding more resources to an existing machine. For example, if we have a RAM of 8 GB, then we increase that resource power to the 64 GB. So while vertical scaling has a certain limit as well, like hardware constant is there, like we cannot increase RAM to an infinite level. So the next approach is load balancing. Load balancing means when we move towards horizontal scaling, like we want to uh, make the different processes of application, then auto scaling group comes in the part, and basically auto scaling group will check the health of a instance, and if the health is good, it will the load balancer will forward the request to that healthy instance. If the health of an application is not good, then auto scaling group will kill that instance and create a new one. So yes, we can do load balancing and horizontal scaling. Another technique of scaling a monolithic architecture is database replication. So basically we will use the sharding here. What is sharding? Sharding means distributing the data um, in across multiple instances of a database. So this is actually a horizontal scaling of database, and we will discuss the sharding later in our videos. So now for the time being, let's keep in mind that yes, we can do a replication of databases and sharding in monolithic architecture. The technique of scaling is caching. We know that whenever we are querying the database more frequently, then what we do is that we store our frequently used data in our cache, for example Redis, and whenever that frequently reading data is requested, then first of all we query it from Redis. If we found it, that is a hit, and we serve it directly. Technique is query optimization. So for example, after implementing cache, if there is a cache miss, then we have to make the request of reading from the database. So what query optimization says that do not read all the data of the table. Instead, extract the data of those columns that you actually need. So this is the query optimization. It also helps in scaling our monolithic architecture. Let's come towards the disadvantages of monolithic architecture. So we must keep this in our mind that the monolithic architecture has disadvantages of, first of all, huge code base, that as there is a single repo and all the services are deployed as a single unit, so after years our code base can increase from 100k lines to 500k lines or even 1 million lines. So it will result in difficult of understanding and maintaining. Also it will result in the bringing of merge conflicts as well. Another worth mentioning disadvantage is long deployments. As I said earlier, that it was a characteristic that easier deployment was there. Like whenever we want to deploy one feature, then everything has to be changed, and that was the characteristic, and that characteristic leads us towards this trade-off, that if we want to deploy one feature, then our whole application will be not available. Our whole application will be deployed, and if we have not achieved horizontal scaling via load balancer, then our users will be affected. Another worth mentioning disadvantage of monolithic architecture is a single point of failure. Means it is not resilient until unless we have done horizontal scaling via load balancer and auto scaling group. So the last disadvantage is scaling problem. The scaling problem is in the sense that we cannot do independent scaling. So although we can do horizontal scaling, and we can have load balancer auto scaling group, but independent scaling and faster deployments are the two major trade-offs that let developers to use the microservices architecture. Besides independent scaling and faster deployment, other challenges are that monolithic architecture is meant for small team of developers and small traffic, but for large team of developers, large traffic, faster deployments, independent scaling, we need another architecture known as microservices architecture. So cover the difference between microservices and monolithic architecture interview question. So the first difference is that monolithic architecture offers a faster development. Why? Because there are less decisions, whereas in microservices architecture we our development is not that much fast. Okay, another difference is debugging, that in monolithic architecture we can easily debug our system because there is a single process, logs are centralized, whereas in microservice architecture we have network request, different services are connected with help of APIs, API debugging is required. And so another difference is cost, that monolithic architecture is less cost, but microservices architecture has operational overhead, cost overhead of DevOps and monitoring tools. Now let's come towards the areas where microservices shine. So in microservices we have services, not a single huge code base like in monolithic architecture. So our system is resilient. Why? Because we do not have a single code base and we do not have a single point of failure. Another area where microservices shine is independent scaling, that we divide our application into different services, and each service can be developed, maintained and deployed as a individual unit. And the last but not least, the area where microservices shine is deployment, that we can have faster deployment as we have divided our systems in services in microservices architecture. So each service can be deployed easily, so deployment of one service will not affect the other service. Now let's come towards the sixth interview question, that when should you use monolithic architecture. So well, if your application is new, means features are not identified yet, so yeah, we should definitely use monolithic architecture. And why we should use monolithic architecture in for new applications? Because uh, uh, because if we use a monolith microservices architecture, then we will be building new services, and as those services will incur cost on us, that is why monolithic architecture is best for the new applications where requirements are changing. The second why of monolithic architecture is that when the team is small, so if the team is small, like 3 to 4 developers, they can easily manage, build and deploy a monolithic application. But imagine an application with 20 services and the team consists of only 4 developers, then it will be difficult for them to develop, deploy and maintain those services. That is why monolithic architecture shine when the team is small. Another why of monolithic architecture is that when the requirements are changing, so as our system is not predictable yet, that is why monolithic architecture shine in this case. Another why of monolithic architecture is that when you need fast development, uh, as we have to do less decisions in monolithic architecture as we have single code base, so our development will be fast. Another why is that it incur low operational complexity. In microservice architecture, we have to decide that this code will belong to which service. That is why complexity will be there. But in monolithic architecture, there is no such complexity. Another is limited budget. That in monolithic architecture, we have fewer servers. We will not have a cost of monitoring services, and less DevOps is required. That is why for the minimum budget MVPs or startups, monolithic architecture shine. Now let's come towards the last interview question of today's video, that why do companies migrate to microservices architecture? As I said earlier, that an independent scaling is not provided by monolithic architecture, and faster deployment is also not provided. Similarly, for a huge team size and for maintaining large traffic, monolithic architecture fails. So microservices architecture shines because it helps in independent scaling, faster deployments. So consider a problem of managing and maintaining an application like we have, as I said earlier, that in monolithic architecture we have a single code base. So imagine we have 20,000 lines. After some years, 2 million lines were added in our code base. So what do you think? It will be easier to understand 2 million lines of code? No, definitely not. So not only understanding will be difficult, but maintaining will also be a challenge for the future developers. So this is the one problem. Similarly, for scaling, another issue is that imagine 5 developers are there in our team, but later 500 developers are modifying the same application. Means team size increases, but the code base is the same, so merge conflicts will occur, dependency issues will occur. Similarly, consider that now we want to scale our monolithic architecture. So as I said earlier, we can scale our architecture, but independent scaling is not possible, as our application is a single code base, not individual services or units or blocks. So we cannot manage or handle scaling for in each independent block. So imagine the search modules is getting 10,000 requests per second, whereas payment module is getting 500 requests. As different requests are for different modules, so each module should handle request according to the requirement, not a single one. So monolithic will scale everything. This is the buggy part. Okay, now move towards another issue is for the deployment side, that in monolithic architecture, as I said earlier, there is a slow deployment. Why? Imagine you have to deploy the payment feature of a food panda application. Since we have a monolithic architecture, for that component deployment we have to deploy our entire application. Entire application deployment will take time, so that is why our development will be slow and it also becomes risky. Now microservices architecture helps us in this way. Similarly, another last but not least is fault isolation, that in monolithic architecture, if there is a bug, like single point of failure is there, if there is a bug in payment module, whole application is affected, whereas in microservices only payment service will be affected, other service will keep on functioning Mark these words that microservice architecture is not required when traffic increases, and senior engineers migrate to the microservice architecture when independent scaling, when deployment challenges, team autonomy, and operational complexity requirements become significant enough that the benefits of microservices architecture outweigh their operational cost. Hope you have enjoyed this video. Please give it a like and subscribe to my channel, and I will meet you in the next one.